Hey, for the longest time, we're told to use host names in networking, right? And the reason for that is because when devices change, it's easier to edit the DNS database to replace a failed host IP address with a new one, rather than configuring all of your equipment again to use a new IP address. So in the case of NTP, when I'm configuring my Cisco router, I'll use a host name. In this case, you can see 4 examples here of 4 host names: 0.asia pool, 1.asia pool, 2.asia pool, and so on. Now these host names are actually names given to a pool of IP addresses. So behind each one of these names is a bunch of IP addresses. If we choose 0 as an example, 0.asia.pool.ntp.org. When you ping this IP address or do a DNS lookup on this IP address, you'll get an A record. Let's just make these up, okay? So bear with me. Let's say we get 1.1.1.1. Now, because there are a bunch of hosts behind here, you may also get another A record, 2.2.2.2, or a third record, 3.3, or a fourth record, 4.4.4.4, and so on. Okay, this is a pool after all. So you may get one of these addresses. Now DNS doesn't really, it's not really too smart. It doesn't know which one to give you. It uses a round robin method to push out one of these addresses each time it's asked. So the Cisco router with that configuration in it will first of all do a DNS lookup for this name and receive an IP address from this pool. And it's true of all of the pool addresses. The router will do a DNS lookup and it will find an IP address. If we go to a command prompt, for example, and ping 0.asia.pool.ntp.org, we'll get one IP address. If we ping it again, we'll get the same one, because the cache on my host now includes that IP address. It's like the computer knows about that IP address already, so it won't find another one. But if I were to use NS lookup, for example, and do the same lookup, you'll see I get different IP addresses. So these are the IP addresses in this pool: 192.146, 210.39, 178, 128, and so on. So I could have received any of these IP addresses in return to this host name. So on the router, when you're configuring NTP, you'll put either a server name or a host or an IP address, right? So either a host name or an IP address. In this case, I've used three of the 4, so let me just edit that quickly. In fact, before I do that, let me just do a show NTP associations, just to see what everything looks like right now. So right now there are 3 servers in there: 162, 202, and 45. Let's add 2.asia in there now. So we'll do NTP server 2.asia.pool.ntp.org. So now in the running configuration, we have all 4, and in NTP associations we have 4 servers, each with different IP addresses. Now 3 of those 4 are not synchronizing. Only the 4th one is synchronizing, 3691.114.86. You can see that I'm using this access list here, ACL NTP peers, to restrict the NTP sources that will be allowed to communicate with this router. So this ACL NTP peers permits or denies NTP communication. if we do a show IP access list, ACL NTP peers, we'll see a list of IP addresses. These IP addresses will represent nodes which are or used to be resolvable from this NTP pool. And you can see of these 4, only one, 3691.114.86, is a match, and you can see that it's hitting the access list there with that 8 matches. But the other 3, they don't exist in this access list. So even though we are using this method of adding this, of adding NTP hosts using a domain name, it's a bit of a hindrance because we also have this static access list that doesn't get updated with DNS. So I had to think of a way of adding hosts to this access list in an easier way than just having the administrator do the following. So normally the administrator would boot the router. The router does an DNS lookup for these host names, and then it would start to work. But when they're missing from the access list, the administrator must do IP access list standard ACL NTP peers, and then permit host, and then add in each of these 4 IP addresses, like so. And then once the access list is updated now, we can see with that addition there, the 200, where did we do it? 162, 159, 162, 159. So entry 230 is the new one. And then over time, the router should start using that NTP peer. We'll start seeing matches on this access list, and things can go forward. But it's a manual configuration, even though DNS is a great way of improving the availability of this node, because you see DNS is there to allow administration of a device or a bunch of devices. So you can, like, if one of those pool nodes failed, quickly the administrator can remove that IP address from the DNS pool, add a new one, and the work can continue without having to reconfigure IP addresses on these devices. So that said, I wanted a quick way to manipulate the access list. So I wrote this brief script, which allows me to do that without having to, do show NTP associations and copy and paste those IP addresses in there. The way I did that was using the iOS shell. It's an extended shell of commands that are available to iOS. It's not Python. It's not TCL. It's separate from that. In fact, when you do show run, you can pipe the commands into the following additional filters, including things like begin, count, include, and stuff like that. So you'll see people use, for example, show run section, I don't know, interface, and it will show you all of the interfaces on that device. In this case, I wanted to show the NTP, the running NTP configuration, the like the associations of the NTP. So, and then I wanted to manipulate that output. So if I do show NTP associations, I want to manipulate this output so that I can extract the IP addresses 162, 159, 201, and so on, rip those out, and then add them to an access list. So this is how I did that. So I've created a simple for loop, basically, for, and this can be just any string, but it's an identifier for the variable. So for NTP, which now becomes the variable, in this executable command, where we do show NTP associations, then pipe it into cut. Now you'll see cut is not listed in the standard iOS shell. Cut is not available, so you have to use something called the iOS shell, extended shell. And to do that, you can either run term shell as the first command, or you can run shell under configuration mode. You can do shell processing full, and then it will permanently allow you to run these extended shell commands, but I don't need to permanently run them, so I'm just going to run them using this term shell command here. So term shell, here's the for loop. So show NTP associations, pipe that into cut. So basically this removes the first line because it includes the word address. Here's the output of NTP associations where the first line includes the string address, so we discount that entire line. The second cut discounts the last line by searching for this string sys.peer, so it discounts that line, leaving 4 lines only. The final cut removes characters 3 through 16. So if we were to look at this IP address here, character 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Is that right? Sorry, 16 there. So the first 16 characters, the characters between line 3, the third and the 16th characters are pulled out for each iteration. So it will do this first line, pull this string, then it will run the next line, pull this string, and finally pull this string. It inserts those into this variable NTP, which then calls the function set NTP ACL. Set NTP ACL is here. Here's the function. And the function is simply configure terminal, which is what we would do manually, IP access list standard, then the name of the access list, permit host, and then we insert the variable NTP, which is basically these characters 3 to 16. Okay, so it's quite a simple thing. But in terms of effort for the administrator, it's a simple case of copying and pasting this into the terminal, and then this will edit the ACL in a more simple way. So for NTP, use host names. Even though the access list that you may use to lock this down will be static, you should use host names because it allows you to react to change outside of your control, especially when you're talking to an external entity. But more importantly, try to automate what you're doing to make your life a little bit easier when you need to fix things like this. So a bit of a jump cut. I didn't really close out the video very well. Following some seconds, I did a show NTP associations again, and now you can see that in a continuation of where we were, we have the same IP addresses which were learned through DNS, but now you can see that they're fully synchronized, stratum 3, 3, 3, and 2. And if we do a show IP access list, what was the ACL, NTP peers, if I spell it right, these 4 IPs should now be in that list, and you'll be getting hits matches on that. So we added 230, 240, 250, 80 was already in play, but you can see now we're getting hits on the NTP lookup, and that's all working fine. So yeah, this was just a quick video, but it was more along the lines of why do we use host names when they offer this dynamic like lookup? Why wouldn't you lock it down and use an IP address? Well, you can use an IP address, but having a tool like having a service like this free ntp.org available to you, why wouldn't you use that? I understand you can go to, I don't know, maybe so you can use the Google time servers. I think they've got like 2 or 3 fixed static IP addresses. You can use that, and you don't have to worry about this this level of administration. But if you want to use features like this, where they have a pool of servers, you're going to have this restriction when you not so much when you configure the NTP, because the NTP server itself, it will react to the host name by doing the DNS lookup and everything will be fine. But when you try and lock it down, when you secure it with that access list, everything goes a little bit to pot, doesn't it? So this video was just really just to show you can use host names in Cisco IOS. You probably should, because it gives you the benefit of this reactivity to external events. But then there are these like nuances that you need to be aware of that can stop things working. Well, anyway, thank you so much, and hope to see you again next time.